Hello, this is Praveen. Welcome to .NET Today is session 5, value type, reference types, and typecasting. So in this particular session 5, we'll try to know what more in terms of value types and reference types, and we'll try to know the difference in terms of both types, and we'll do some typecastings as well. Okay, so here are the agenda items. So first we'll list out the difference in terms of the value types and the reference types. So we'll try to know the key characteristics in terms of the memory allocation and the copy behavior. Okay, and we'll also try to know the storage structure of both value types and the reference types as well, and we'll do some implicit casting and explicit casting. So here we have to know about parse, try parse, has keywords in casting as well. So, and finally we'll see what are checked and unchecked blocks and some hands-on labs as well. Okay, so let's get started. So here are the list of the difference in terms of the value types and the reference types. So like in the earlier, like we have seen all the data types, right? So which data types comes under which particular categories. So here are the list of numerical floating data types which comes under the value types. And this, if you can see, there are like character, boolean, enumerator, and structures. So structure is also like a class in C sharp which stores on the heap memory, like it is for the small data. If you wanted to store small data amount of data, so we'll use structures instead of classes, and it is faster than the classes because it is stores on the heap and it directly fetches the data. Okay, and whereas in terms of the reference types, the classes are stored in the heap, and it takes some it's more time consuming than compared with respect to the structures. Okay, so here are the list of the reference types, like the object, string, arrays, class, interfaces, and delegates and nullable types, all that comes under the reference types. So here are the categories in terms of your which data types comes under which value type or the reference types. If you want me to just show the previous our writings, I can show you that. So if you can see, with respect to our previous session, like all the integers and the floating types are comes under the value types. Okay, and the particular value types are stored on the stack memory, whereas the string data types and other data types, like all the store on the all called as the reference types, and it stores the data on the heap. Okay, so here if you can see, like here is memory allocated on the stack. So all the value types, the memory is allocated on the stack, whereas it in the reference types, the memory is allocated on the heap. Okay, and the reference of that particular variable can be stored either in the stack or the heap. I will show you when I connect to my tab, and I will explain you that in detail. Okay, so performance like value types are much faster than the reference type, because with the data that it holds the data directly through the stack. Okay, and it comes to the reference type, heap is much slower than compared to the stack. Okay, like nullable support, like in terms of the nullable support, like value types can have the nullable support with just by a question mark. Like it, when you declare a particular integer or any particular numerical values, long or float or double with a question mark, so that particular variable can handle the nullable types as well. So nothing but it can store the nullable nulls in your data types as well. Okay, so whereas in the reference types, nullables, you have to explicitly handle that one. Okay, if you have to, if a particular class object or a particular string, you have to mention that particular string objects has to be, array object has to be checked with respect to the if that particular variable is null or not. Okay, so other in terms of the boxing and converting, like when you wanted to store a particular value type to a on a particular heap, so you can have the boxing type. So if you can see here, having an integer and storing this integer value on a object type, so that now this particular integer type value is stored in the heap instead of the value type. So this is called the boxing. So when you wanted to convert a value type to the reference types, you need something called as boxing. So that is nothing but you are trying to store a stack data to the heap. Okay, And when it comes to the reference type, you doesn't require boxing or unboxing. It is inherently a reference type. Nothing but like the reference types, like your string classes subjects are already stored on the references and doesn't need any unboxing. Okay. So copying data behavior, it copies the value where it copies the reference of the point of the particular memory location. So let me show you that. Yeah, copying behavior. Let's see in the stack. Let's say I have declared an integer x is equal to 10. So it directly stores the data into the stack. So it directly holds the data on the stack. So the x variable. So when you give these assign values to the y variable, so it copies the complete data from x to y. Okay. Whereas in the stack, like if it's a reference types, it doesn't host the data directly. It has a reference. So you have a functional pointer, like nothing but the address of the particular actual data. Here, the actual data is stored on the stack. Here, here the actual data is not stored directly on the heap. Like it will have this particular reference, and this particular reference, the address of that particular memory location can be either in stack or heap. So it can be on the stack also, this particular reference. Okay. So nothing but the actual data is stored on the heap and the reference of the particular memory location is stored on the stack. Okay. Let me connect to my tab and explain you this in detail. Okay. So I'm going to explain you the basic how the storage structures are in the value types and the reference types. Okay. So here is the value type. Okay. Let's say I'm just declaring int x is equal to 10. So when you declare a particular int x value type and you assign certain values, this particular x variable data, actual data is directly stored on the stack. Okay. Something like this x 10. This 10 is directly stored on the stack. Okay. And when you say y is equal to x, nothing but you're giving the x value to y, so that now y you will have something like 10, and this nothing but the copy of x value is given to y value. So the original content, original data, the directly holding of data is directly holding that particular is copied to this particular new location. Okay. In, Whereas in terms of the reference type, so if I say something like string str1 is equal to hello world. So str1 does not hold the data, actual data directly. It doesn't hold the actual data directly, but it has a reference point. So something like this. Okay. str1 reference hello world. So this is the actual data, correct? So this str1 does not hold the actual data immediately. Like it does not hold the actual data, but it holds the address of the particular location. Address of the memory address. Okay. If I can say like memory address of the actual data. So if you can understand this, like str1 does not host the actual data directly, but it has this particular memory address of that particular actual data is stored on this particular str1. So when I say str2 is equal to str1, I am copying the data from str1 to str2. So the actual date reference type is stored on the str2. So nothing but str2 will hold the reference to. So nothing but it copies the reference, not the actual data. The reference will be holding this, but the memory address is copied from str1 to str2, and this particular hello world actual data remains the same thing. Okay. I hope you get this particular point. If if you if you want me to show me the slide in terms of this, like see it, the stack, like it has the reference in between in terms of storing the actual data. Okay. Now let's see typecasting. Okay. So as of like in terms of this particular slide, the previous slide, if you can see, like you have the integer types. This in the integer types, you have certain level of similar set of integer types, like it could be a s byte short, integer long, and byte u short, and integer. So in the floating types, you'll have float, double, decimal, and string, character, string, char, and in the string builder, and other data types as well, right? You have set of categories, right? So sometimes in the typecasting is sometimes the value of one particular data type has to be stored in another data type. Some example, like in terms of the byte to be stored in an integer, or integer into byte, something like. So first we'll try to know what are the ways that we can store in the similar data types, nothing but the casting in terms of the same data types, like byte to integer, or integer to byte, long to integer, and integer to long. So sometimes you have to store the values of one particular data type to the another data type based on your business requirement. Okay. So similarly, from the same similar data types, like you will cast in terms of the float to double, and double to float, and float double to decimal, and decimal to double. Okay. So nothing but we'll try to cast first with respect to the similar data types, and to the other data types also we'll try to cast nothing but a string to integer, or integer to string. Okay. I hope you get this point. So sometimes in terms of your applications, you have to store the data of one particular data type to another data type. That could be within this particular similar data types, other data types also. So nothing but from the integer to the string, and string to the integer. So once I explain you that in detail, so you'll get to know in detail. If I show you this slide, okay. For example, I have a byte value, and I can store that into the integer value. So just for now, you understand, like all the lower, when you're trying to assign the byte lower data types to the higher data types, so you doesn't need explicit, no, you doesn't need any casting. So that is nothing but the implicit, like directly you can assign. So when you're trying to assign the higher level data types to the lower data types, nothing but the integer to something like integer to byte, so you need explicit casting. Okay. If you can see this particular table, similarly, like for integer to long, and long to integer. So here is the simple examples in terms of convert cast typecasting with respect to the similar data types, nothing but the integer data types. Okay. I will connect to my tab again, and I will explain you that in detail. Casting between similar data types. So let's say, let me take first one example, like 8 I byte value, okay, is something like, let me write it like something like this. Let me byte to integer, and integer to byte. Okay. First we'll try to take a variable that and assign that to the integer. Okay. Byte b value is equal to, let it be 100. Okay. So the byte range is 1 to 225. If you can remember, like with respect to my previous slide, with respect to the previous session, like the byte value is from 0 to 255. Okay. The range is 0 to 255. And the integer range is very high, right? Like in terms of something like -3 to 7, something like, from like which has something very very bigger, higher range when compared to the byte. So now I'm giving this particular lower range value to the integer. So int I value is equal to b value. So I'm assigning this value to this b value to the integer I value. So in this particular case, like all the possible values of byte is will be definitely fit into the all the possible values of integer, right? So nothing but the range of integer is very high, and it can fit all the values with respect to the byte values. So nothing but we doesn't need any casting, which is called implicit casting. I can directly assign. Okay. So when it comes to the integer to byte, okay, integer to byte, let's say I will give int I value is equal to 100, okay, and I wanted to assign this particular value to the byte, okay, something I wanted to show like byte b value is equal to I value. But if is all the possible values of integer can be fit into this particular byte value? No, exactly no, right? So in this particular case, we need a casting, explicit casting by saying that to give byte here in the bracket, I will write it again here. In the bracket, I write byte and write I value. So nothing but I'm giving the I value and I wanted to make sure this particular I value falls in the range of byte. So what does it mean? What does this particular uh, line of code does it influence? When I'm trying to assign integer value to the byte, so I'm making sure it falls into this particular category. Okay, so in this particular king, like I can say this is the explicit casting. So if there is like if the value of the I value is greater than 255, let's say it is like 1000, so there is a data loss here, right? So the explicit if you want, if you're trying to cast, so there is a data lost here. If the value is high, the data is lost, data loss happens. So that's what we are trying to make this particular explicit casting. Okay, explicit casting and making sure that value is in the this particular range. Okay, let me give another example. Okay, this is one example. So let me try to convert from int to long. Okay, and later we'll convert long to int. Okay, so int I value is equal to some thousand, some hundred. Okay, and I'm assigning this to the long. Okay, long I L value is equal to I value. Is this fine without a casting? Definitely it is fine, because all the values of integer definitely can fit into the all the values of the long. Okay, so because the range of long data type is much higher than compared to the integer. Okay, this is nothing but the implicit casting. Okay, so when it comes to this particular long to int, so let's say I have this long I value, I L value is equal to 100, and I wanted to give this particular to the integer. Int I value is equal to L value, sorry, like I'll write it again. I int I value, I have less space here. Int I value is equal to int of L value. So this is nothing but the implicit casting, explicit casting. So here it is saying that when I giving this that particular long integer, it is making sure it is having within the range of that particular integer. You will get assigned that particular integer I value, will get this particular L value only if it falls under this particular integer range. Okay, and it gets assigned. I hope you get what is implicit casting and explicit casting. Now let's say I take other examples in terms of the float, double, and decimals. Okay, once you do the programming and give the examples of this, like you'll get to more understanding very easily. So but we'll try to cast in terms of the similar data types. Okay, float, double, decimal. Let's say I have float f value is equal to 1.2.5, something like something 123 dot something 123.5. Okay, and I'm asking to, and I wanted to give it to the double. Okay, double d value is equal to f value. Can I directly assign? Definitely I can directly assign, because all the values of float can exactly fit into the double values, because the double range is much more. The double precision value is more than compared to the float values. Double is like 15 to 16 digits, and this is only float is only for till 7-digit precisions. Okay, so when it comes to converting from double to decimal, we need explicit casting, something like this. Okay, double d value is equal to something like 1.03.5. Okay, and I am assigning that particular to the decimals. Decimal, sorry, to the float. Float f value is equal to float of t value. Let me write here. Float f value is equal to float of d value. Here we need an explicit casting over here. Okay, so nothing but when we are trying to convert any lower data type to the higher data type, we doesn't need any casting. That is nothing but the implicit casting. When you are trying to convert from the lower data types to the higher data types, like you doesn't need any casting, but when you're trying to convert the higher data types to the lower data types, you need explicit casting. Okay, something like we'll see, I have less space, like other data types, like when we are trying to convert from string to integers or integer to string. So something like the other data types, like string str1 is equal to 1 2 3. So something I wanted to store this in the integer, so I will store something like int value is equal to int dot parts of this particular str1. So something like I will use int dot parts. Okay, so let me show that in the slide. See here in the floating data types, like float to double, I know doesn't need any explicit, I doesn't need any casting. I can directly use the implicit casting, I can directly assign. But in terms of the double to float, I need explicit casting. That is, I have to make sure that is definitely into this particular same, that falls into the category of this particular float precision. Okay, similarly string data types, like I'm trying to convert from char to string, so I can use ch dot to string, that I can store that in this particular string value, doesn't need any casting. Okay, so that is nothing but the implicit casting. So whereas in I'm trying to convert a string data type to the char, so definitely I need an explicit. So similarly from string to integer and integer to string, like we are using something called as parse. Okay, so here are these few more examples in terms of the other data types, casting in terms of the other data types. See, I have something like object to string. Okay, object to string. So I can use, like, I can assign the object to the string values, making sure that that falls under the string categories. Okay, similarly integer to object to integer. So I'm giving the object type to the integer and just making sure that it's under the similar category of integer. Okay, same like with respect to the object to bool and object to nullable types. Okay, and object to decimal types as well. Okay, so when we are trying to parse the values of one particular data types to another data types, like we will see parse. Okay, so you'll have something called as int dot parse, like you will have the data type dot parse. Okay, so if you want it, you'll also can have the try parse, like when we are trying to show whether that particular typecasting is parse is valid or not. Okay, something if it is like, oh, if this particular 1 2 3 dot something, like if I have an invalid data, like instead of 1 2 3, I have some ABC value, so which is not an integer type, right? Okay, so in that particular thing, I wanted to make sure that particular is valid or not. Is that particular data type is not valid or not, I will use the try pass. Okay, I can also use hash keyword as well. So I can hash the hash keyword, like I can specify the hash keyword to convert the object to the string also. Okay, now let me connect to my Visual Studio and show you some examples. Okay, yeah, see here, I'm taking 1 2 3 and I'm passing that to the string, and I'm passing this particular string 1 2 3 to integer type. So I'm writing here. So before that, I'm just trying to show you this one. So the thing is like here, if it is having a invalid data, this throws an exception. Okay, so I will show you that one example also. See, it is showing 1 2 3, but if you have this particular one, instead of I'm initializing some dummy data. Okay, I'm wrong data. So this is not the valid integer. So this is not, I cannot parse this particular this invalid integer to, and I cannot assign to an integer data type, right? So here he throws an exception here. See here, it's throwing an exception. So in order to handle this kind of an exceptions, like I wanted to make sure if that particular really valid and showing me that successful or unsuccessful. So I can use this particular in try pass. Okay, for example, if it is something like invalid data, so this if this particular success will have this particular false value. Okay, the output will have the false. So it is going to this particular in false, and it is going and it's telling that this is the invalid data. So this helps to validate the data if it is correct or not. So if it is given the right values, so obviously it will goes over here and it is prints the output 1 2 3. Okay, it given me the 1 2 3. So similarly, casting between the other data types, like if you have the hello world object and I wanted to store this, I can use the has as well as keyword. So object variable has this particular string, then that will store the output values as well. So nullable types, like in terms of the nullable types, like the this particular, when you declare a integer with question mark, so it can give hold the nullable values also. So if it is 1 and it has the values, then it will prints that particular value, and if it is null value, it gives 0. Okay, so let me show you these two things. Let me comment out this. Okay, object value, I'm trying to show that as an integer out, as a string output. Okay, okay, I got that output, and I have the valid of this particular. I do not have a nullable type. So if it is not nullable, then if it has some value, it is going to print me the give the output. Okay, so if it is not something like null, it is going to give me the 0 output. So this is the safely unboxed to the of nullable types. Okay, so it's giving me 0. So this is the way that you work with the different data types and different typecastings as well. Apart from this, like you will also have checked and unchecked blocks in C sharp. So something like if you are adding two numbers, so that addition of the two numbers of an integer data types exceeds that particular range of that particular value. For example, if you are trying to do something like byte result is equal to byte A plus byte B. So imagine something like you have something this kind of a situation. So the byte value is 0 to 255. Let this value is let be 244, and this is 1. Oh, so something like 1 or 10, 100, something else. But the byte result is only like it can store 0 to 255, right? So, and it is crossing the 255 range. In that particular, if you are crossing the range, maximum range, so we have to wanted to show throw some exception over or throw exception, then you have to use the checked blocks and unchecked values if you doesn't wanted to check the overflow. So here I have the maximum value here, which stores the maximum range of an integer, and I say +1, that is going to overflow. And this particular overflow kind of an things, then I can have this checked one, and I can have the unchecked with if you don't wanted to check this kind of a that kind of a behavior. Okay, so benefits is like prevents unintended result due to overflow. Okay, so this kind of a checked and unchecked blocks will be help to handle the overflow exceptions. Okay, I hope you understand our session today. I'm going to uh, recap this particular thing. Like in this particular thing, you have learned what are the differences in terms of the value types and the reference types, and also you have seen the difference in terms of the storage structure and the copied behaviors. And we'll see the implicit casting and explicit casting, like implicit casting in terms of the casting in terms of the similar data types and the other data types as well. Okay, you have seen what is parse, try parse, has, and checked and check plasmax. So see, try to know much details in terms of the casting. So try to look into this particular chat and this table, and try to do some programmings and see the difference in terms of the converting to the similar data types, like lower data types to the higher data types, and higher data types to the lower data types, and the different data types as well. Okay, if you can remember this and analyze this, and if you can make in casting in terms of the similar data types and other data types, then that will be most helpful when you're working with the complex data types and complex casting in your applications, like where dynamic objects. So this will be more useful. You may have to convert a dynamic variable which can be a date list object, or it could be a JSON object. You have to convert that particular JSON object to your list object, or that particular JSON object to a C# class or something like that. So that kind of a complex kind of a situations you may have to cross. So we'll come across more into the further sessions, but try to know in much terms in terms of the casting. So most of the applications that you work in the C#, like it will involve lot of casting and boxing and unboxing in terms of your value types to the reference types and your difference type to the value types. And you may have to work with more in terms of the casting and types casting. And so have a look on to these particular examples and all the particular whatever we have gone through this within this particular chat. Okay, so let's catch up in the next sessions. Like next sessions we'll try to work with the arrays. Okay, our next sessions is working with the arrays, and we'll also work on much more in terms of the we'll try to know more about arrays in the next session. Okay, thank you for watching. Let's catch up in the next session. Thank you.